Hello and welcome to our lesson on radicals multiplying rational expressions. First, let's talk about some rules that you need to know. In order to multiply a radical term, you need to multiply like terms. Remember, any whole numbers are considered like terms to another whole number, and any radicands are considered like terms to any other radicands. So radicands and whole numbers are not like terms to each other, so you can't multiply a whole number times a radicand. Now, quick review. Your whole number sits outside of the radical sign, and the radicand is what sits inside of the radical sign. And then your teeny tiny number is still called your index. Here's the steps. Multiply the whole numbers and keep them outside of the radical sign. So that would be the 4 and the 6, and you keep them outside the radical. They don't move in. Multiply the radicands and keep them under the radical sign. So you would multiply 2x and 22x squared. Once you do all that, simplify any of the radicands if you can, and then be sure to double check your multiplication. So let's give it a shot. Okay, first we're going to multiply 4 times 6, so 4 times 6 is 24. And then we're going to multiply our radicands. So we're going to take radical 2x and multiply it by radical 22x squared. Once we do that, we're going to end up getting radical, because they're still under there, 44x to the third. Because when you multiply exponents, you really don't. You add them. So you add 2 plus 1, and you get 3. Now, you have 24 radical 44 x cubed. But, you remember, we have to fully simplify any radicands. So if we take 44 and we prime factor it, it ends up being 2 times 22, and then we can break this down into 2 times 11. So we have a pair of prime numbers, so they come out. So you really got the 24 that was there times the 2 pair that's coming out. If you have x cubed, you really have x times x times x. Pairs, you've got one pair, and then the other one needs to stay inside. So you've got your radical. Your 11 from your 44 is all alone. He goes back in, and so does the x from the x cubed. We're almost done. Now we just have to finish that out. So if we take 24 and we multiply it by 2, we're going to get 48. And we still have our x, radical 11x. And this would be our final answer from multiplying these two terms together. Now, a quick way to look at it, just to kind of glance to see if you're even close to being correct, your answer should be larger than the two terms that you started with. 48x is a lot larger than 4 or 6, so that looks to be about right. Then you would go back and redo your prime factorization and double check your multiplication. Let's look at another example. Alright, so we have 13x, and we are multiplying it by 6. So if we're going to multiply 13 times 6, you're going to end up with 78, and that's for your whole number with the x behind it. Then next, you're going to take your radicals, and you're going to multiply them together. So you're going to take radical 9x cubed, and you're going to multiply it times radical 21x. 9 times 21 is going to be the first thing you're going to do, and you're going to get 189. And then you're going to multiply x cubed and x. Remember, when you multiply exponents, you really have to add them. So it's x to the fourth. That's great, but 189x to the fourth is not fully simplified, so we're going to have to break it down. Now, you can use your calculator, you can do a factor tree, and if you do a factor tree, 189, you can definitely break it down by 3. So 3 goes into there 63 times. 63 is going to be 3 times 21. So far so good, I've got primes. And then 3 times 7. Remember, since this is square roots, we're looking for an index of 2 or pairs to pull out. We can pull out a pair of 3s, and the 3 and the 7 have to stay behind. Now we also have to look at our x to the fourth. So we've got 4 x's, which means we've got 2 groups of x's and no leftovers. So we've got 78x from the original whole number multiplication. Now we're multiplying it by those pairs that we could take out. A pair of 3s and 2 pairs of x's. And then we have stuck under the radical the lonely 3 times 7. Almost done, we have to finish simplifying. So we're going to multiply these two, and then under the radical we need to simplify as well. So when we multiply 78x times 3x squared, we're going to get 234x to the third, because remember when you multiply exponents you really add them. And then under the radical sign you're going to get 21. So this right here would be your final answer. And 13 times 6, 234 is a whole lot bigger than that, so it looks kind of just glancing at it to be right. Now you would go back and recheck, check your multiplication, and recheck with your factor trees. Let's try another example. Now we're going to deal with decimals. It works the same way. And this time, look, we don't have any variables. So first thing we're going to do is we're going to take the whole numbers, 5.2, and we're going to multiply by negative 7. So if we do that, we're going to get negative 36.4, and we're going to have to figure out what that cube root underneath is going to be. So actually we're going to multiply 9 times 27, cube root of 9, times the cube root 27. We're really just multiplying these whole numbers underneath. And when we do that, we are going to get 243. Looks good, however, 243 is not fully broken down. So if you go do that, you can take 243, and it would be 9 times 27, obviously, because these were the two factors before, and then 3 and 3, and then 9 times 3, and then 3 and 3. Okay, because we've got a 3 as an index right here, we're looking for cubes or groups of 3. So we've got 1, 2, 3, and then we've got 2 3's lonely left over. So the group of 3's comes out, and it gets multiplied by the number that's already out there. And then we still have that cubic root of the 2 lonely leftovers, which is 3 times 3. If we finish multiplying everything out, we're going to get negative 109.2. And then we're going to have cube root 9. So right here would be our final answer. And 109.2 is definitely bigger than 5.2 and 7, so just glancing looks like it could be right. Again, go back and recheck all your multiplication and recheck your factor tree as well. The best way you can do that is just reworking the problem. Make sure that you get the same answer twice. Usually that means that you did it right. Okay, let's look at our next example. You've got negative 6x times negative 8x cubed. So let's take those first. A negative times a negative times negative 8x cubed. When you multiply a negative times a negative, you get a positive number. 6 times 8 is going to be 48. Remember, when you multiply exponents, you really don't. You add them, so that leaves you with x to the 4th. Now we're going to deal with our radicals. We've got 3x to the 5th, and we are multiplying that by radical 15. So let's multiply 3 times 15. That's going to be radical 45. And you still have your x to the 5th. Okay, so if we put it over here, we've got radical 45, x to the 5th. The problem is that there's no index here, which means we're looking for a square root, and these numbers are definitely not fully broken down, so we need to go ahead and do that. So if we take 45 and we factor tree it, 5 times 9 and 3 times 3. I've got primes. I've got a pair of 3's so they can come out. So I'm going to take that 48x to the 4th, and I'm going to multiply it by the 3's that came out. Now let's look at x to the 5th. And how many pairs of x's do we have? We have 1, 2 pairs, and a lonely guy left over. He's going to end up hanging out with the lonely 5. So we need to add in these x squareds. You need to write it right next to the 3. It means multiply it. And then under the radical sign, you have your lonely 5 and your x. Now, finish it out. You have to multiply those two outside terms together, and then you'll be all done. So once you do that, you're going to get 144 x to the 6th radical 5x. So here it is, right here. And that's going to be your final multiplication answer. Again, you would go back and double check just to make sure you did all your math correctly. 360, and we're multiplying exponents, which is a lie. We're actually adding them, so we're taking 1 and 4, which is 5, y to the 5th. All right, we're not done yet because this is not fully simplified if we're trying to find a cube root. So we're going to take 36 and we're going to break it down. And if you take 360, break it down, you can do 36 times 10, and that's 2 times 5. And then you have 6 times 6, and 3 times 2, and 3 times 2. Now, this is cubic, so we're looking for groups of 3. Well, I see I've got 1, 2, and 3. I've got a group of 3 2s, and then I've got lonely 3, a lonely 3, and a lonely 5. So, we're going to take 2y squared, multiply it by that group we were able to pull out, which was 3. And then we have underneath the radical 3 times 3 times 5, which is 45. Now look at those y's. We've got 5 of them. 1, 2, 3, 4, 5. And we're looking for groups of 3. I've got one group of 3 with 2 lonelies left over. So the one group of 3 comes out. This tells me the index is still 3. And then I've got 2 of them left underneath the radical. Almost done. We just have to finish filling out.
You did something wrong.
Uh-oh, what did I do?
It's not 3y, it's 2y.
Oh, yeah, I see. That's okay. Alright, so we'll do the slide over. You don't have to go back and edit that then.
Yeah, that's fine.
Okay, ready?
Yes, go ahead.
Okay, so let's look at our final example. We have y times 2y. And remember, when you're multiplying with exponents, you're really not. You have to add them. So it's 2y squared. Now we're going to multiply the cube root of 25y and the cube root of 15y to the 4th. So, cube root, 25y, and we're multiplying it by the cube root of 15y to the 4th. Okay, when we do that, we know we're going to get cube root. And that one is going to be 360 for the whole number. And when you multiply exponents, you really don't. You add them, so you have y to the 5th. All right, looks good, but we're not done yet because we can definitely break down these according to cube roots. So we're looking for groups of 3. So let's take 360 and break it down. That would be 36 times 10. And 2 times 5. I've got prime numbers. Then it's 6 times 6, which would be 3 times 2, and then 3 times 2. Now it's cubic, so we're looking for groups of 3, so I need 1, 2, 3, and I've got a group of 2's, 3 of them, so I'm going to take it out, and I'm going to have 2y squared times 2. And my leftover guys, 3, 3, and 5, go back underneath the radical sign. Remember, this is cubic. So 3 times 3 is 9, and 9 times 5 is 45. Now let's look at the y's. I've got 1, 2, 3, 4, 5 y's, and I'm looking for triples. So I have a group of triples right there, and 2 left over. So I'm going to add in my group of triples right here. And then I am going to put my other 2 right there. Now I have to finish multiplying those out. So 2 times 2 is 4. And then I have y to the 2nd and y to the 3rd. And remember, you're going to add them, even though it says to multiply. So I've got y to the 5th. I still have a cube root and 45 y squared. And that would be my final answer. And then you would definitely want to go back and recheck all your multiplication and make sure you did your factor tree correctly and that you added all your exponents, because you don't multiply them, you add them. So for a quick final review, multiply only like terms. Only the whole numbers get multiplied by the whole numbers. Only the radicals get multiplied by the radicals. All the whole numbers need to be multiplied by themselves and kept outside the radical. And all the radicals need to be multiplied by themselves. And you need to simplify those radicals once you get done multiplying them out. And that's it for our lesson on radicals, multiplying rational expressions.